Alright, gang, here we go. This is Chem 1, Unit 2, Part 3, the mole. Alright, so we're going to talk about moles, what they are, not the little ground animals, but chemical moles, okay? And we're going to talk about doing some math with them. We're going to talk about dimensional analysis. Should be a lot of fun, alright? So moles are really useful because they allow us to keep track of the amount of whatever it is that we're talking about. Okay, so it's the SI unit. So remember, SI is the System d'International or something like that. So really that means it's the big important value that we use to calculate this stuff. And it's the SI unit for the amount. Okay, so it allows us, remember, atoms are stupid, ridiculously tiny, and if we were trying to keep track of the number of atoms, like we'd be using, vastly huge numbers all the time. So the mole allows us to take these vastly huge numbers, condense them down so they're not so big. Think of it as kind of like keeping track of the number of eggs you have as by the dozen. So if you have 12 dozen eggs, like 12 is a lot easier to remember, 12 dozen, as opposed to having 144 eggs, So it's kind of the same idea, only on a much bigger scale. All right, it's abbreviated as MOL. Okay, and it's the amount of the substance that contains as many particles as there are atoms in exactly 12 grams of carbon-12. So you had carbon-12 atoms. Remember, this is the mass number. Okay, so that's the mass number. So if you had 12 grams of carbon-12, okay, then the number of particles there are in that is equal to 1 mole. So that's how it's defined. So we call it Avogadro's number, okay, Avogadro's number, and it's this number here. So start memorizing. I'm just teasing, okay, 6.0221415 times 10 to the 23rd, all right? We'll use this value. We'll round it to 3 digits. Okay. Occasionally, you'll hear me refer to it as 6.022, and that's just purely out of habit because that's what I used all the way through college, and that's what we use in Chem 2. So don't get freaked out if you all of a sudden see an extra 2 appear when I'm working through a problem. All right. So if you have 1 mole of copper, okay, you have 6.02 times 10 to the 23rd atoms. All right, so let's solve a couple of problems here. All right, so we want to find how many moles of silver, remember it's Ag, are in 3.01 times 10 to the 23 atoms of silver. All right, so in order to solve this type of problem, we're going to use a trick called dimensional analysis. Dimensional analysis allows us to keep track of the units as we're flipping between units. So we're going to write down, so this is how you're always going to solve these problems, okay? So you're going to write down what we're starting with, 3.01 times 10 to the 23rd, all right, atoms, all right, and we got to convert it to moles, all right? So we'll draw this like this, and we'll put atoms at the bottom, and we'll put moles at the top, all right? Now for according to Avogadro's number, right? Avogadro's number, 1 mole equals 6.022 times 10 to the 23rd. So for every 1 mole, we have 6.02 times 10 to the 23rd. All right? So notice that our atoms are on top here, and the atoms are on bottom here, so that means they cancel. Atoms cancel with atoms, and we're left just with moles. All right? Now be careful when you punch this into your calculator that you put the denominator in parentheses. Okay? 3.01 times 10 to the 23rd, and then we're going to divide it, but we got to put it in parentheses. Otherwise, if you don't put the parentheses before the 6.02, and after the 10 to the 23rd, then you'll have divided by 6.02 and multiplied by 10 to the 23, which gives you a really, really wrong answer. All right, so if you want to get the wrong answer, don't put your parentheses. All right, so when you punch it in correctly, you get 0.49975. Okay, 0.497, and we'll round it to 3 digits here. So 49, so it rounds up to, I'll cross that out, so it rounds up to 0.500 is what I got. So, moles of silver. Okay, so in 3.01 times 10 to the 23rd atoms of silver, there are 0.500 moles of silver, which makes sense, right? Because 3.01 is exactly half of 6.02. Okay. All right. Now it says how many atoms of magnesium are in 0.500 moles of magnesium. So now we're going to start with what we know, which is the 0.500 moles of Mg. All right. And we're going to convert that to atoms of magnesium. So we're starting with moles, so we'll put moles down here, and then we're going to atoms. All right. So, but we use the same ratio. For every 1 mole, there's 6.02 times 10 to the 23rd. All right. So notice our moles cancel with our moles, and we're just left with atoms. All right. So 0.500 times 6.02 times 10 to the 23rd. Okay. Don't forget your parentheses. All right. Just always put them in, even though you don't necessarily need them on this part. And you should get something like 3.01 times 10 to the 23rd atoms. All right. And we could be even more specific by putting magnesium for Mg for magnesium. All right, so that's how you'd solve those. Those are pretty simple. Okay, now that's kind of easy, but it still makes it tricky. Like if you had a chunk of salt and you're trying to figure out how many atoms of salt there are, there's not really a good way to do that, right? Like you can't really take a pair of infinitesimally small tweezers and start counting out atoms to figure out when you have a mole. Not only that, but it would literally take you forever to count out that many atoms of silver or of salt. So what we do instead is we're going to use mass to do it. Okay, so this allows us. I like to refer to it as counting by weighing. Right, counting by weighing, meaning we're going to use the mass of our sample in order to figure out how many number of moles we have. Okay, so in order to do this, we're going to use the molar mass. Okay, now the molar mass happens to be the atomic mass of the element. Okay, so remember, if we had like carbon, remember up here it says 12, and then underneath it might say like 12.01. Remember that from 2 parts ago when we were talking about isotopes. So that 12.01 is our molar mass. And the units for this are in grams per mole. So essentially what it's telling us is that there's 12.01 grams for every 1 mole of carbon. All right? So down here we've got 1 atom of sulfur. How much does that weigh? Well, we find sulfur on our periodic table, and it's 32.065. Okay, so 1 atom of sulfur weighs 32.0, we'll just say 07 AMU. All right. Okay, so 1 mole of sulfur is equal to, it weighs 32.07 grams. So if you wanted to get exactly 1 mole of sulfur, then you get your tub of sulfur and you'd bring it over to a balance, and you'd have like a little weighing dish, and you'd scoop out until you get to 32.07 grams of sulfur, and you know that in your little weighing dish you have 1 mole. So notice that we can count the number of moles of sulfur we have simply by weighing. Okay, it's a very powerful tool. All right, so let's say we want to find the mass in grams of 3.5 moles of elemental copper. So we've got copper, and we want to figure out, and we know maybe through some experiment that we have 3.50 moles of it, and we want to figure out how much that would weigh if I needed to carry it around. All right, so we're going to write down what we started with, 3.50 moles of copper. Okay, and we're going to convert that into mass. All right, so we're going to use the same system we did before. We're starting with moles, so we got to put them on the bottom so they cancel, and then we're going to grams, so we'll put grams up top. All right, so moles cancel with moles, we're left with grams. Now, where do we get our ratio grams to moles? Well, we just look at the atomic mass. So we find copper on our periodic table, and copper is 53.55. All right, so it's 53.55 grams per 1 mole. Now, one trick that you can use for now is that whenever you're doing these conversions, the 1 value will always go with moles. All right, so 3.50 moles of copper, and then so we're just going to take 3.50 times 53.55 divided by 1. So 3.50 times 53.55, and we get 187.43. Okay. So we'll just call it 187 grams of copper. So if you had a sample and you knew for sure that it was 3.50 moles of copper, then you know that that thing weighs about 187 grams of copper. All right. All right. Next problem here. A chemist produces 11.9 grams of aluminum. How many moles of aluminum were produced? All right. So we're going to write down what we started with, 11.9 grams of aluminum. All right, how many moles of aluminum were produced? So we got to convert it to moles. All right, so grams of aluminum, that's what we're starting with. So we'll put grams of aluminum in the bottom, and we got to get to moles of aluminum. So we'll put that on top. Okay, notice grams of aluminum cancel with grams of aluminum. All right, remember 1 always goes with moles. Now the mass of aluminum is 26.98. Okay, according to this periodic table, your values may vary. All right, so we take 11.9 divided by 26.98, and we get 0.441 moles. All right, so if we were doing the an experiment and we know that we weighed it and we're like, well, we know we made aluminum, all right, and it weighs 11.9 grams, and we want to figure out how many moles of it we made, we simply take 0.44, or we simply divide it by the molar mass, and it gives us the number of moles. So if we made 11.9 grams of aluminum, we know we really made 0.441 moles of it, all right? Now this is the mole roadmap, okay, and this helps you identify which way you go. You will not get this on an exam, so you do need to memorize it, all right? So here's our 3 bits, okay? So the moles are up here, okay? The number of atoms are down here, all right? Number of atoms, and then the mass in grams, okay? So we can go from grams to moles by using the molar mass, okay? Notice mass to gram, and we can go from the number of moles to grams by using the molar mass. So we can go either direction. Notice how if we're going from moles to grams, then the moles go on the bottom, and if we're going from mass to gram, or grams to moles, then our mass goes on bottom and our moles go on top. We can also go from moles to atoms by going through or by using Avogadro's number, and vice versa. Now notice here, this part is where life gets trickier. Okay, we cannot directly relate mass to number. We have to use moles, so we have to use the molar mass. Okay, you almost can think about it as the moles being the middle ground. Okay, so if you have grams and you want to get to number of particles, okay, I'll just put a number. Okay, if we want to get from grams to number, we have to go through moles first. Okay, so to get from grams to moles, we'll use the molar mass. Okay, and then in order to get from moles to number, we'll use Avogadro's number. Avogadro's number. All right, so let's do a couple practice problems. All right, so we want to find the mass of 2.04 times 10 to the 35th atoms of bromine. So remember our map here. We're going from number of atoms, okay, and we got to get to grams. Okay, we want to find grams, but we're given number of atoms. We have to go through moles. So this is going to be 2 steps. So this is a little bit more complicated. So we have 2.04 times 10 to the 35th atoms of bromine, all right, and we need to get to grams, so we're going to have to do 2 steps, all right. So we'll put atoms on bottom because that's where we're coming from and we need it to cancel, and we have to go to moles first, so we'll put moles up top, all right, and we know that there's for every 1 mole we have 6.02 times 10 to the 23rd atoms. Right, that's easy. Now we have to go from moles to grams, and we use the molar mass, right? So we'll say, all right, one more step. Now, so these guys have canceled, right? Atoms have canceled with atoms, and we're just left with moles. And we need moles to cancel now so we can get to grams. So now we'll put moles on the bottom so that they cancel. You see how that works? Moles up here, moles down here, they cancel. All right, and then we'll put grams up here. Well, we know that moles will always get the 1, and then we find the molar mass of bromine. On this periodic table, it's 79.90, so we'll put 79.90. All right, let's say 2.04 times 10 to the 35th, 2.04 times 10 to the 35th, all right? Now, everything that's on the top gets multiplied, and everything on the bottom gets divided. All right, so we're going to divide it by 6.02 times 10 to the 23rd, all right? And then we're going to, and don't forget those parentheses, because if you don't do the parentheses, you're going to get the wrong number, times 79.90, all right? So I got, let's see, 2.04 times 10, I'm just double checking, 2.04 times 10 to the 35th, divided by parentheses 6.02 times 10 to the 23rd, times 79.90, and I got 2.71 times 10 to the 13th. 2.71 times 10 to the 13th grams of bromine. All right, so if you have 2.04 times 10 to the 35th atoms of bromine, then that's going to weigh 2.71 0 or 2.71 times 10 to the 13th grams of bromine. That's gonna be a big chunk of bromine. That's pretty heavy. All right, let's try another one. So how many atoms are in 10.5 grams of calcium? So you've got 10.5 grams in, like, say, your supplement or something, and you want to figure out how many atoms you're putting into your body. All right, so we're going this time, and last time we went from atoms. Here we went right to left. Now we're going left to right. We're going from grams to atoms, so we have to go through moles again still. All right, so we got 10.5 grams of calcium. All right, so we're going to put grams of calcium in the bottom because that's what we want to cancel. And remember, we have to go to moles first, so we'll put moles up here. All right, and we know we put 1 with moles always. All right, until in the future when that changes. But for now, okay, for this unit, 1 with moles. All right, you got to be 1 with the mole. All right, so calcium, molar mass is 40.01. 08. This periodic table is different than what I'm used to. Okay, and then moles go on the bottom now because we got to get the moles to cancel, and we're going to atoms, right? And so we put 1 with moles because you got to be 1 with the mole. I like that. And then the number is Avogadro's number, 6.02 times 10 to the 23rd. All right. And then, so we're going to take 10.5. Remember, we divide by everything in the bottom and multiply it by everything in the top. So we take 10.5 divided by 40.08 times 6.02 times 10 to the 23rd. And we get 1.58 times 10 to the 23rd. 1.58 times 10 to the 23rd atoms of calcium. Calcium is Ca. All right, so there's our answer. So if you had 10.5 grams of calcium in your supplement, you're really ingesting 1.58 times 10 to the 23rd atoms of calcium. That's quite a bit, right? So that's it. That's the end of chapter 3, I think, in the textbook. So you got a checkpoint for this. You can go ahead and do your practice, do some practice problems, and right around the corner, we're going to start into nuclear chemistry. All right, good luck.